So recently, Crew AI integrated with Phoenix observability. Phoenix is the open source project from Arise. Um, so Crew AI integrated with Phoenix to push so that when the Crew AI crew runs, the traces can be pushed to Phoenix. So I explored that feature today. I'm going in this recording. I'm going to show how to set this up and then share some of the observations, right? So to get the Phoenix observability layer, you will need these packages, right? These are the 4 packages that you will need. So I pip installed these packages. I pip installed this also, right? And after that, I run this command python 3 dash module phoenix.server.main. I want the Phoenix server to run on 6006 port and host 0.0.0 serve, right? So when you run this, your Phoenix server, the observability server, will be active, like it will run, right? So if you see my server is running here. So if I do a 0, right? This is my server running here. And you can see I have already ran 2 times, so 2 traces are there, right? But how did I set this up? To set this up, things that I need is so the trace SDK dot trace provider, right? So trace provider comes from so trace SDK, right? Trace SDK comes from OpenTelemetry.sdk, right? That's from there the trace comes in. So trace SDK dot trace provider, the span exporter, right? OLTP span exporter. This is the class which is exporting the spans and the traces to, this is the location. This is the endpoint of the observability service, right? This is running at 0.0.0 6006, right? So this I didn't go into the details of this class, but looking at the class and what the input it takes, basically this probably is exporting the traces to this endpoint. And then the span processor, the simple span processor is what I instantiated, added the span processor to the tracer provider, right? And then set the tracer provider to the tracer provider, right? This 1, 2, 3, 4, 5 lines, and then I did a crew instrumenter dot instrument. And so if you do only this, only the crew AI constructs or the traces will be pushed in. But if I say, because crew AI is underneath using LangChain, if I use LangChain instrumented dot instrument, I'll get more granular traces, right? So these are the 2 lines, and this setup is what we need to push traces into the Phoenix observability layer when crew AI runs. So after that, I created a normal crew AI agent flow where I have a manager agent whose uh, task is to, based on the question, it will route it to a physics teacher or a maths teacher. I really don't know whether it is actually working like that, but looking at the traces, it doesn't look like this is working, right? Or this is working like the way I want it to, right? I wanted, like, once a question comes to teacher manager, based on the question, it will either route to the physics teacher or the maths teacher, right? So the teacher manager, then I have the maths teacher, which answers only questions related to maths. Physics teacher answers only questions related to physics. And then the task I set up, actually, this is not required since I'm using a uh, hierarchical process. And in the manager agent, I'm adding the teacher manager. I don't need to add the manager and the task in the crew, right? In the crew, I just need the maths teacher and the physics teacher agent and the task, right? So this is a task for the manager teacher. This is the task for the physics teacher. Then I created the crew. using these two tasks for manager and physics. Then the math teacher and the physics teacher are the agents. This is a hierarchical process. I put memory equal to true. Memory manager agent is my teacher manager. This will manage the uh, hierarchical way. This will manage the process. And I did planning equal to false. I thought that if I just wanted to see what happens with planning equal to true and false, right? But I ran the latest run is true planning equal to false, right? And then I said teacher underscore crew dot kickoff question, what is Pythagoras theorem, right? And when I run it, it starts pushing it to um, Phoenix. So if you see that I have already ran it, right? And this is the latest run, right? And this is how it looks like the crew creation of the crew, the task execute core, task execute core. My observations were like it is very difficult by looking at this to see which agents ran, right? This task looks like this is the manager role, but the next task is also manager role, right? Um, so I am like it was not very obvious that which agents are running, right? So if I click on any one of them, right, it gives me the entire flow. So it goes, it shows that the first task, right? It shows actually, so if I collapse them, right, let me collapse them and we'll see. So there are two tasks only I can see, and looks like both the tasks are manager role. So don't know why, because I said like if it is a manager should route it to either physics or maths, right? But from the traces, it was very difficult for me to actually find out what is happening. Right? I was not able to follow it. I can see the chat open AI. Looks like this is the manager, but then the next one, this also it says you are the manager, right? Next, this one looks like this went to maths teacher, but why to manager? How that flow, right? That is not very clear, right? I think this is something that there is a room for improvement. So it is good that the traces are coming here, but to better understand the traces, how the flow is happening, I think some more decorators will need to be put into the solution where I can actually annotate. I should be able to label, right, so that it is easy for me to understand, right? But anyway, this is definitely a good first step because this is what we need, right? This reminds me of my microservices days when I used to use Zipkin and Tether for distributed services to find out how, like if something failed, right? How where the failure started and how it actually traced back to from the source to the point where the failure happened, right? That helped in quicker debugging and all, right? So I think this type of solutions will also help in debugging distributed multi-agent solution. That's all I wanted to show today. Thank you.